Welcome to the grand finale of this Excel sheet automation for our tank problem. Just a reminder, in the previous screencast what we did was we took the tools like Goalseek and Solver to automate this case study, and they did their job pretty well, but if you recall, then they were not able to automate our Excel sheet lively. I mean to say, if you had changed the dimensions like length or radius, there was no change in the height of the liquid filled in this tank. So in today's tutorial we'll talk about how to overcome those issues. We will be using a method called bisection method to solve that issue. Now bisection method is used for the function following the type f of x equals 0. So it's necessary that the total volume calculated by these two sections in these equations must be subtracted by the total volume here in order to match this expression to what we call as the baseline of bisection method here. How we are going to use the bisection method in our case here? Then it's like, first let me show you a graph. In the x-axis it's the function of the height, which is the volume in our case here, and let's say we'll be dealing with the case when the volume of the tank equals 500 gallon initially. Okay, and this x-axis here is the function of height in inches. Now if you plot this equation, then you will get a graph somewhat of this nature. Okay, so of course it has a beginning point called A, and it has an ending point called B, and in the middle, in somewhere between these two points, there is a point in the graph where the functional value equals 0, and this particular point is the point of our interest. So how this bisection method works is, first of all we calculate the functional value at point A. We then again calculate the functional value at point B, and somewhere between these 2 points, midpoint, we calculate the functional value here as well. And we notice the change in the nature of the graph between these points. I mean to say, if there is a change in the sign from moving from this point to the midpoint, then we assume that our solution lies in this section. And if suppose there is a change in the nature of the function in this portion, then we completely neglect this half here, this half here, and we keep on zooming in and zooming in and zooming in. I mean to say, we keep on performing the iterations and round of iterations and round of iterations until we decide to a appropriate value of h, where the function corresponds to the change in the signature. So this much about the bisection method. I've set up my spreadsheet like this, where there is the length of 12 feet, radius of 3 feet, as we have seen in the previous screencast, and as I said, we'll be dealing with the functional value of 500 gallon in our case here for now. So let's make a little setup for the bisection method. We have initial value as 0, this value at A here, and we have the final value as 6, because final value it's always the 2 times of radius, which is 6 in our case, because the radius we have assigned here is 3. I have already plug this whole mesh into this particular shell, and don't forget to subtract the obtained volume from the cell B6, which is in our case the volume in feet here. So the midpoint, it's the average of low domain, it's the average of point A and point B here, which is obtained from average function in axial. Press tab, select the initial point, select the final point, and press enter. Okay, you have the midpoint of two boundaries, and you can simply copy your formula and paste it here, because the refreshing is always relative in axial until and unless you have changed it, and likewise copy the formula here. Okay, now for the first round of iterations we have done our job, and what you see here is the function has the negative value at the point A and it has the positive value at the point B. That means our solution lies between the points 0 and 3. So we can neglect this part of the graph. How we perform here is by the application of if case. If functional value of low and functional value of mid is equals 0, that means if has changed this sign, because if it's negative and if it's positive, then the multiplication of positive and negative is always negative. That means it's always less than 0. Then I'm interested to set the low boundary as low, and if it's false, then I'm interested to shift the low boundary as middle. I press enter. And likewise in the high, how we automate here is again use the application of if functional value of low times functional value of mid. If it's less than 0, then that means our solution resides in this half. Then I have to change the value of V to the middle, else I will stick with the value, high value as it is. Now you may take some time to absorb this formula here, and after that you can simply select them and drag them down here. Likewise drag it down here, and now we have automated this table, and if we select and drag them down to the couple of rows here, then oops, I've encountered an error here. So let me quickly find out what the problem is. And okay, if you have noticed it or not, I need to subtract every time here by this cell value in B6, which is my total volume. And since I have not inserted the dollar signature here, so it's taking the relative of this sixth row, that is D6 F6. So at first be sure that your subtracting factor is always constant, that is B6 in our case. And once you have improvised the problem, you simply for now just delete those values which you are going to reproject them again. You copy this corrected formula and paste it in the F mid, and I can paste it in the Fi. Copy again and paste it in the Fi, and make sure that it's always subtractive factor, it is always total volume, which is constant for the case here for now. And again drop it down to the second row, and now you can confidently select all of them and drag them down to 20 rows below, and you have your solution as function of x, that is at midpoint, which in our case corresponds to 1.228. Remember that all of those scenarios here have the units of feet, so you just point it to the feet cell, the value of mid here, and this shows that when the tank is filled up to the volume of 500 gallons, then the height covered will be 1.3 feet. Now you change the value as from 10 to 12 to 10 feet in the length, then you see it's all reiterated and the value has been reassigned here as 1.4, just like in a second. So this is how the iteration we have created it a more live. Likewise, you can also change the radius from 3 to 4, and you can see it has gone a series of iterations here and plug the value as output. Okay, now after the successful implementation of bisection for the volume corresponding to the 500 liter, what we are interested now here is not only for the single volume, we want to perform this bisection within a fraction of second for all of those volumes corresponding from 100 to 3300 gallons. So how we can do is that, if you remember in our previous screencast, then we have utilized the data table for the sheet automation, and this is again what we are going to do here. First of all, it's very important that you assign a pointer corresponding to the height in inches, and you select the table including the pointer all the way down to your desired table, and from the data verify analysis you select the data table, and here the input is only one dimension, which is again the total volume in gallons. You select this cell which corresponds to the total volume in gallons, and you press OK. So you have your all height filled automatically via the data table. Now I changed the length from 14 to 12 feet and radius from 4 feet down to the 3 feet, which was the scenario in our previous screencast, and these were the outputs in our previous screencasts. And if you check the outcome from the goal sequence solver to what we have performed today, that is bisection method, then they correspond to the same value. So in this tutorial we have learned how to use the bisection tool to automate the case study, and though it's not a VBA portion, it somewhat gives you a live solution. I hope you guys have enjoyed. Thanks for watching. Keep smiling, keep learning. Bye bye for now.